Hi, everyone. Excited to get started.
Are you?
Oh my goodness. Today, Mia and I will be talking about Axe for AutoML. So we've been talking about this all week, but Axe is the platform that we've built for adaptive experimentation here at Meta. So we apply this to a number of things, basically anything that looks like a black box optimization problem. And one of the main places that we apply that is for automated machine learning and at various stages of the pipeline. So me and I are going to be going through an interactive tutorial for this. So before we get too into our slide deck, I'd ask everyone who wants to follow along to open up their laptops and go to this tiny URL to open our Colab notebook. The first cell is a pip install. So while we're going through the slide deck, it'll be good to get that pip install started. I'll give everyone a couple minutes on this.
Folks who are able to get to the collab, this is bringing them to a collab. This tiny URL.
It says we need access,
Oh, goodness.
or is it just me? I don't know.
I also need access.
Oh, there we go. Do we need to give us?
I'll get it going. You can talk.
We'll get started on the collab in just a moment. Thank you, Mia. And yeah, for those of you who are still not able to access the collab, we'll have an update soon. So getting straight into this is a slide that some of you will be familiar with, but like I was saying, right, adaptive experimentation pops up all over the place in AutoML. The second blue box here is where people really think about it. For HPO is like the absolute classic example. In network architecture search is something that people are much more interested these days because there's that structure there that we can take advantage of. But there's this huge pipeline. We can think about feature selection as like this massive binary AutoML problem. We have all of these post-training optimizations like quantization that we can do that can affect either model quality or some of the serving properties. When we push a model up to infra in order to serve predictions as fast as possible or do inference, there's a million little flags we could be touching there that could affect how much memory we're using, how quick these queries are coming back. Things like that are really important to optimize when you're working at scale. And even after that, there's online parameters that can feed into your entire ML product that could have a real effect on top-line metrics like how your users are experiencing the platform. So each of these is a black box problem, and they each have their own little idiosyncrasies that need to be sorted out and handled when you're working on an experimentation platform. So, right, like there are many different things that our adaptive experimentation platform needs to solve. There's a million different things that it needs to be good at. We really focus on candidate generation in this field, sometimes early termination as well with things like hyperband and ASHA. But there's all this tertiary things that we need to worry about. We need to worry about managing the state of the experiment. We need to worry about making sure that we have some analyses and observability, things like plots, tables. Sometimes we want to automate deployment. We want to automate metric fetching. We want to make sure that we're saturating our experimentation resources, so running as many trials as we're able to. All of this kind of orchestration stuff is totally different from if you see yourself as just a blowtorch developer and are developing new models or new acquisition functions. There's all this overhead that needs to happen before you can start deploying your new methods onto real world problems. So that's what we accomplished with Axe. We have this API that is all about controlling experiment state and orchestrating experiments. So we have this client, which is our API, and users communicate with this client to set up their experiment, configure their optimization goal, whether that's optimizing a single metric, optimizing in constrained space, optimizing a Pareto frontier in like a multi-dimensional, multi-objective space. And then on the back end, Axe can also handle this orchestration for you, where it's deploying trials, reading metrics from sources, and handling that entire closed loop. And it's platform agnostic. So you can send this off to AWS, you can send this off to Slurm, you can read from TensorBoard, you can read from SQL tables, whatever you need there. So it's this real plug and play interface. And right on the bottom, by default at least, it's always backed by BoTorch. So all of your kind of candidate generation stuff that you're familiar with is handled in BoTorch there. And yes.
So are we allowed to ask questions during this?
Yeah, absolutely. I think we have a mic for questions.
Okay, it's just a quick question. So how much is thank you. Okay, how much is it restricted to BoTorch? So could I replace BoTorch by something else?
Absolutely, yeah. There's a little bit of extra creature comforts if you're working in BoTorch, but it's a totally generic interface. So if you have something, Nevergrad say, and if you wanted to work on some evolutionary algorithms, you could absolutely plug that in, and it's very simple. We'll get to it later in the tutorial. For those who do use BoTorch, there are some little extra features, so you can just like plop in acquisition function classes implemented in BoTorch and things plug and play a little quicker. But because that's what we're really familiar with, but totally agnostic there. Cool. I'll kind of blaze through a little bit of these slides for those who saw me on Tuesday, but right when we're dealing with this very diverse set of problems throughout the AutoML pipeline, you wind up needing to support a ton of different modalities of experimentation. So right, like I talked about, single objective, multi-objective, constrained, and also all of these strange search spaces. Maybe sometimes it's fully continuous hypercube like we're familiar with. Sometimes there are discrete dimensions. Sometimes we have constraints that make it so that we're not operating on the cube properly. There can be noise. There can be early stopping concerns. We can be very resource constrained, stuff like that. And we're really pleased with the results that we get with default settings in Axe. We've focused a lot on making the kind of classical GPEI loop very, very strong in Axe on a wide variety of problems. And we were happy to report that we were doing very well and performing at state of the art. Axe is a very large open source project. We have dozens of developers committing, and we have commits going every day. So we're really happy with the robustness of our code base. We try and make it very easy to develop in a stable way through having a lot of unit tests, fully typed everything, and this nightly benchmarking setup, which runs internally every night on a variety of internal and external benchmarks to make sure that we're not having any regression sneak in and that we're continuing to have state-of-the-art performance. Also, this is an especially important point for this audience. We really are active on these GitHub issues. So if there's any questions about how to use Axe, any requests for PRs, feature requests, things that you've implemented that you would like to see landed onto master, absolutely reach out. We get a lot of great ideas from the community here. So making sure that we're encouraging community participation from the research community is something that means a lot to us. As far as usage, internally, we have over 1,000 users at Meta just for AutoML, and we're running tens of thousands of experiments. We also use this pretty heavily for online experimentation. For those of you who remember that first chart, that's the pink box that loops back in and informs us how to do offline training based on metrics from real users. And we have a much smaller user base there, but we're running some really impactful experiments that we're very happy about. So we have a large investment in this online optimization as well. This is something where if you have any questions, this is a great time about Axe and BoTorch. This would be a great time. I know a lot of people in the research community are familiar with BoTorch and maybe use it to implement algorithms that they publish on, unless people are familiar with Axe. So we really wanted to nail down the difference between these two software platforms, even though it's the same team that's managing both of them. So Axe is this full experimentation platform, right? We are managing experiment state, we're managing this orchestration, we're controlling observability. And it is all about trying to run an optimization with real world data and having real world effects. BoTorch is this research library for Bayesian optimization. So it gives you all the primitives that you need as far as surrogate models and acquisition functions and likelihoods and optimizers. But running it with real data does wind up taking some work. You have to do data cleaning yourself. You might have to do some ad hoc stuff for storage or trial state management and deployment. So this really is targeted towards BO researchers or people trying to do something extremely custom, and to try and figure out exactly what, how they want their optimization to perform. Axe, on the other hand, is for people who are either researchers looking to use real data or people in the real world just trying to optimize these functions. So we go all the way from researcher to practitioner here. And the goal is to be useful to both of those segments, to make sure that it's simple enough for the people who need something very simple, and it's flexible enough for people who are trying to do something new and exciting. Like I mentioned, we're always looking for new pull requests. There are a million different things that we think that the community could be contributing to. Third-party runners and integrations, runners being the things that allow us to deploy trials. So I know earlier in the conference, someone asked about RayTune and how Axe is supported there. This is how we'd imagine that we could support ourselves there. As well, acquisition functions, non-GP-based Gaussian processes, right? Every year we see a lot of new exciting stuff in the black box optimization community. And seeing that brought into BowTorch is always very exciting for us. And then going one step further and seeing it brought into Axe so that we could deploy it on real world data and see how things look there would be extremely, extremely exciting. For people who want to learn more about how to contribute to Axe, you can go to our GitHub to read all of our contributing practices and to talk to us through GitHub issues. I'm gonna check in with Mia on that collab link.
Yeah, I'm gonna duplicate the slide. We're gonna have a new one right now.
Beautiful. Okay, I will, tell me when that's done, I'll refresh and give you guys the tiny URL again. What's that?
I've got a question in the meantime.
Oh, perfect timing.
Yeah, so it's mostly for your previous slide about Axe and BowTorch.
Mhm.
And I'm wondering if I made a contribution to BowTorch, how long till that is usable in Axe? Like, how do you feel about, because you separated out to two libraries, is there? Sort of-
Yes. So I guess the way that that would typically work is if someone contributes to BowTorch, this is just like adding a new module into the BowTorch library. Where we would want to contribute that into Axe is by making Axe dispatch pick that module from BowTorch. So Axe is a very robust dispatch chain that will look at your search space, look at your problem, look at everything that the user has told Axe about the goal of the optimization, and pick and choose which BowTorch elements to use. And if someone had implemented a new method in BowTorch and it provided really compelling results over single task GP and log EI, which is what we like to use by default in certain cases, then we would like that heuristic to go in and pick that new module so that it automatically gets sucked up into Axe and deployed for all Axe users.
Yeah, and that's the way that it would become defaulted into Axe. If you just wanted to use it yourself, section 5 of our tutorial will go into like using custom BowTorch methods within the Axe framework.
Perfect, thank you.
See the slideshow, it's the very last one.
Oh, you put it at the end? Perfect.
Let's try again.
It's a smallish library. Hopefully the pip's not too bad.
It's pretty fast.
Big thank you to the Cornell Tech Wi-Fi.
Well, not yet. It's not done yet. Somebody give me a thumbs up when you get it. Yay.
And give another thumbs up once everything has been installed.
That's the difference.
Yeah, here, take the podium.
Be the same. Like all my copy pasting was.
Did you have to do it on a personal Gmail account?
Yeah. Okay, should we?
Is the link gonna work after this session?
Yeah. Yeah, the link will continue to work, the collab will stay live, and that's also why we put in this like about Axe section at the very top. This is pretty much a lot of what Miles just went through, so I won't go into it in super detail right now. But yeah, so the learning goals of the tutorial, we recently cut Acts 1.0. We did kind of like a silent big update. Shout out to Miles for leading that effort. So you'll learn how to use our 1.0 API. We are also going to go over using Acts for hyperparameter optimization, multi-objective optimization, demonstrate some early stopping within Acts, as well as constrained optimization and mixed optimization. And then like we talked about, if you have like a custom blowtorch implementation and you want to get the benefits of using the Acts framework, we'll go into that. So the hope is that this will be, you know, interactive. It's a long session, so like we don't want people just to fall asleep. So please ask questions and like shout out and be engaged throughout the session. So at the very beginning, we're going to establish a baseline. So we're going to use this baseline throughout the remaining sections of the tutorial in order to compare Acts to the performance of a baseline. We're going to use the digits data set here, and we're going to train just, you know, a classic MLP classifier with some reasonable defaults. Did we run this yet, Miles? No?
Not even connected.
Great. So yeah, let's go ahead and everyone go ahead and get started on establishing this baseline.
Right, this is a baseline that I think most people are familiar with. Is just the MNIST data set on some sklearn classifier. So we should get pretty decent performance out of the box, but potentially nothing special.
So we're probably seeing this, just an output, show you things are looking good. And then we have a baseline score.
Yeah, are people getting around the same baseline score? I know there's some non-stationarity here, but something around 0.8.
Perfect. Cool. So then the second section, this is like where we actually start talking about things that are interesting. This is hyperparameter optimization within Acts. So the goals here is that we're going to familiarize ourselves with the Acts API. And then we have some core objects within Acts that I think most folks are familiar with the terminology, but you know, they're called like search space and optimization config and trials. And so that's like what composes an Acts experiment. So getting familiar with those, understanding the experimentation lifecycle, and then also being able to review the results here. So first we have our experiment configuration. So within Acts, the experiment object, it keeps track of our entire optimization process. And this is where you can define your search space and the optimization config. The search space is the set of parameters that define the boundaries of the optimization problem. And they can be range parameters, choice parameters. If you have a fixed parameter, it can be like a choice parameter with a single option. That's like the equivalent of the legacy fixed parameter that we used to have. And they have different types. And so here we initialize our client and then do parameters. Yeah.
Can you do complex dependencies between parameters? So as in this one's only active when this one is set to a particular value?
Yeah, we do support parameter like constraints.
Yeah, we won't show that off in this, but one of the options on this choice parameter config, which we'll get to later, is an option called dependence, which lets you specify the whole tree in a way that you'll be familiar with if you've used config space before.
Cool. Great. Yeah. So we ended up in our user version getting this. So now we're going to run our configure optimization, but we're getting an error because of the ... dots. What do we think we should put in here in order to configure our experiment?
Parameters.
Yes.
At least.
Miles looked afraid when I said we were getting an error. Great, we didn't get an error anymore.
It's a great library.
So now we're going to define the goals of our problem. We're going to do this with our optimization configuration call. And so by default, we have client.configure optimization is the method, and you pass in a string. If you just pass in the string, we'll assume that you want to maximize this metric, and that string is like your metric name. If you multiply it by -1, we'll assume that you want to minimize it, and then you can do more complex things as we describe in the text here. You may also optimally configure outcome constraints here as well. We'll get into that a little bit later. So here we have configure optimization, and we want to maximize a metric named score. So in order to do that, we would just say, right? Whoops. Great. Next, we're going to attach our baseline. So we're going to establish what we're going to compare to. And in order to do that, we'll need to have both the baseline parameters, and then we'll also tell Axe what the result of that baseline was.
So this is technically an optional step, but I think it's always valuable to do, and it's something that gets skipped a lot in HPO optimizations, right? We often kind of know what a sensible guess is for a good hyperparameter configuration, whether SK1 provided some kind of sensible defaults, or we have a good intuition as expert practitioners. So it's always helpful to kind of seed the Gaussian process in a region that we think is pretty good. Oftentimes people will just skip straight to random search to initialize everything, but if we have a good intuition, we should always go for it.
And that provides, like Miles is saying, like an initial data point. That's nice to have for the model. Does anyone want to help me with what I should put in here?
-3.
Is that the answer?
No, scroll up. What did we use for baseline?
Carl's gonna give me the wrong answer. Miles, why don't you tell me?
You're gonna make the GP fit that.
All right, no one wants to help me, that's fine.
-4.
And we did a batch size of 400, is that right?
Yes, 400.
Cool, and so now we're seeing that we've attached a trial and we've marked it as completed. So now we're going to actually run the experiment using Axe. So we're going to execute 25 trials. We're going to ask Axe what the next trial should be, use it, and then return the information back to Axe. And this is like more interesting. It's kind of the meat of the situation here.
And it's gonna run in a separate process.
No, this is this is just going to run in your single Python thread. If you wanted to multi-thread this, you absolutely could, but this is just your kind of typical training loop with one outer loop on top of it, where we're asking the client to get the next trial and complete it, or attaching the data. So if you wanted to set this across multi-core, you could absolutely go for it. There's no reason that
The way to do this would be implement custom runner.
And the way, if you want to fork, for instance, separate process or run on a different machine, would be implement custom runner.
that's how we would do it. There's you can manage things yourself if you were really into using a multi-processing library, but using the custom runner is and exporting that to an off-board machine is the way that we do it.
Thank you.
Yeah, and in this situation where getting one trial and returning information for one trial, you can, get multiple trials at once as well. Cool. So in that time, we were able to complete 25 trials. Axe each time said, hey, we got this trial, we've marked it as completed, kind of just to give you a progress report as you use it. Now we're going to review the results. So let's get the best parameterization from the experiment. Yay, it's not the baseline, it's one of our results. So that's great. So it looks like trial 20 was the best. And then these were the parameters that it had. To remind ourselves, the baseline score was 0.78 and we achieved like 0.98 essentially. Then we have client.compute analyses. This is like a built-in. Oh, yeah.
Question. Is there like a random seeding for acts? Is it expected that we would be getting different results in this case, but could you do deterministic experiments?
There is a way to control as best we can, determinism in acts. There's a random seed that you can pass into the client, and that will make sure that at least your initialization will always be the same. But between some randomness that happens in the sklearn training jobs and some floating point accumulation happening when we're fitting the Gaussian processes, we wind up finding out that it's pretty difficult to nail down all of the non-determinism.
Thank you.
I'm sure if you used something besides Gaussian processes in VO, that you could probably have an easier time getting things to totally replicate every time.
But it is very easy to pass in the seed.
Yeah.
Yeah, it's exposed within the API. Cool. So then this is like the default visualizations that Axe automatically provides. We're pretty proud of these results, and then we think they're kind of interesting. So here we see the metric effects. So this is like for score, how did we do at each trial? And then it's called arm name because these are single arm trials. So each trial has the same like corresponding arm name. There are options where you may have like multi-arm trials, and so that's why it's index on arm name instead of trial. So first we have our baseline, then we can see that we're doing the center of the search space, and then we go into Sobol. And so like Sobol doesn't do so good, but as we go on, now we're using Blowtorch for generation, and our score progressively gets better, which is what we like to see. The reason that we show two effects here for score is that on the left-hand side, we have the modeled predictions for score, and then we have the observed predictions. And so this is to like infer some noise and assume that like, there could be noise or non-stationarity. And this is like our modeled predictions for how the result will be. We then have like a summary of the experiment if you wanted to look at it in more of a data frame style visualization. And then we have top surfaces, which I think we actually highlight here in a second. And then we have our cross validation plots so you can see how the model is performing. So what is top surfaces? Top surfaces tells you which parameters, either individual parameters or parameter interactions, are the most influential and important for the metric that you're interested in. This is like a more advanced visualization than like some of our, not competitors, but friend libraries may offer. And it uses Sobol indices to inform the parameters that are the most important. If it's a single parameter, we then will also provide you with the slice plot. And if it's a parameter interaction, we'll provide you with the contour plot for the two of those. Any questions about this basic setup? Yeah.
So the contour plots are based on the prediction of the surrogate model, or how do you essentially interpolate and extrapolate beyond the points that were actually evaluated?
Yeah, I think Carl actually implemented this.
So it is based on the. So it is based on the. You asked the question, right? So it's based on the surrogate model predictions. All of these plots, all of the plots that are either surfaces or slice plots are.
Cool. So continuing to move on, we thought it'd be a good place to start by just showing like a very typical hyperparam optimization for an sklearn model. I think that's something that most people would be familiar with, and this was a good way to get started and become familiar with the language that Axe uses and all of the methods that we need to interact with in order to configure the experiment. But obviously it's a very simple and kind of straightforward optimization. If we wanted to do something a little more interesting and maybe a little more exotic than the standard HPO case, we could try doing a joint HPO and NAS. So what we're going to do here in this next section is run a new experiment, again, on the same MLP using digits, but instead of just perturbing the optimization hyperparameters, we're also going to change the architecture. So we'll change the layer sizes and the activation functions and hopefully get some better results there. One thing that our team has been really interested in for AutoML specifically for a while now is this idea that different phases of the AutoML pipeline should be tuned jointly, right? We don't know for one architecture that these hyperparameters will be good and transferred to another architecture. So having the ability to run these experiments at the same time is potentially going to lead to some really compelling results for us. So we're going to just scroll straight through here, and this will look very familiar to chapter 2. But instead of those range parameters, which were representing continuous dimensions, we're going to use some more exotic parameter configs here. So we have this choice parameter config, which is going to give us a categorical parameter. We have a little ellipses here for these values, which just represent the activation functions we can have in the MLP. Are these going to be ordered or unordered? Feel free to shout it out.
Unordered.
Yes, that's right. So we're just going to configure that. And then these range parameters, it's important to highlight that these are integers now. Axe will just handle this under the hood. We'll pass the full integer range down to blowtorch, and the mixed integer optimizer will handle things over there. But so we're now going to get a much larger search space that has these HPO parameters and NAS parameters. So we're going to go ahead and run that to get a new experiment configured. Now we're going to try and configure a little more exotic of an optimization config. So when we're doing NAS, one of the things that we know is that it's not only going to affect the quality of the model, it's also, oh, Carl, do you have something?
What is an optimization config?
An optimization config is how we tell BO what the goal of the experiment is. So we're often really concerned with just optimizing a single objective, but that doesn't really reflect what our kind of true business needs or true experiment goals might be. So for this example, obviously we want score to go up, but we know that these NAS parameters are also going to affect the size of the model. So maybe we want to kind of look at the relationship in the trade-off space between score and size. So I'm going to create a new metric called n parameters here, which we'll just use as a proxy for the size, and we'll report that back as the sum of all the layer sizes. And we'll see how that trades off with score. So when we configure optimization, this objective is going to get parsed out by our symbol parser. And we can do really complicated things here. We can say that we want score plus n parameters to be optimized. We could add in some scaling factors here. So maybe we say like, oh, we care about the number of parameters half as much. So we write that expression in there. But in this case, we want to look at this trade-off space. So we're just going to pass in a tuple of different objectives. Also, exactly. Also, right, of course, we want to maximize the score, but we want to minimize the number of parameters. We like a smaller model. So we're going to multiply this by -1, and that'll redirect the optimization to minimize. We're also going to start adding in constraints here, just to give those a demo. Based on the last model, we're pretty sure that we're going to get a score better than 0.8. Right? That's what we got for the baseline. So let's just imagine that we're not really interested in anything less quality than the default parameters. So I'm going to write in here that we want a score that is greater than or equal to 0.8. And for this hypothetical, let's also imagine that we're going to try and put this model on a device that's very small. So maybe we don't want any architectures that have more than 300 parameters. Oh, no, this was 1024, my bad. So, right, this will guide our optimization to show us a trade-off space, but not the full trade-off space, right? Even if there's a model that gets us perfect accuracy, but would never be big enough to fit on our device, it's not going to try and hunt that down. Or if there's a model that is super tiny and runs very quickly, but has terrible accuracy, we're not interested in that either. So being able to express all of those opinions as we're configuring the experiment is really important to make sure that the optimizer doesn't get stuck focusing on something that we're not really interested in.
Any way to plug in custom objectives?
Custom how so?
I don't know, some business specific formula.
Oh, so the question was whether it's possible to plug in a custom objective that's some formula that could be specific to your domain space. I think what's important here is to remember that this is not how we're actually calculating the metric here. These are just kind of combinations of labels. So if we had some very bespoke logic for how we model quality that was reported back as one scalar, what we do here is we would just add in another label for like my special model quality. And then during our training loop, when we're reporting back to AX, we would make sure that we report back a number for that special name. So we're not actually doing any kind of computation here and figuring out metrics. We're just making sure that AX has the appropriate labels, and the easiest way to express that is often through this symbolic parsing. Does that answer the question?
Yeah.
Cool. Once again, we are going to pass in the baseline, just this is data that we have. You can imagine if this was a model that took thousands of dollars to run, we would want to keep every single piece of data and not throw anything out. So I will toss in the architecture that we had in the original baseline run.
Which is what? It's hard to read from here.
Oh, so sorry. It was 100 for every layer. Does this improve the readability at all? Yeah. Thanks. Oh, and yes, the n parameters on that is obviously 300. Make sure to run your cells in order. So once we have everything set up, we're going to run through the exact same training loop again. We are going to create an outer loop where we have 25 trials. We're going to ask AX, what should these next trials be? And we're going to unpack this parameters dictionary that it provides us into the MLP classifier. So let's go ahead and click run there. And we should start seeing results kind of come through as AX churns through its generation strategy.
So this became like a much more interesting experiment configuration because now we have multi-objective optimization, we have parameter constraints, we have outcome constraints. We have parameter constraints. Yeah, we do. Outcome constraints. So it's a bit much more realistic. So I thought it was more interesting.
And this will take a little more time to run. I'll talk about what AX is doing while it's happening. But so when you set up a problem, AX decides how these points should be generated from a kind of grab bag of Bayesian optimization techniques. And it will order them in a DAG with the order that it thinks will be best suited to solve the problem. It shows you what happens right here in this first line of the logs, where it's going to do sample the center first, which is just something that empirically we see as a fantastic choice to center first and get the Gaussian process started. Then it'll do a little Sobol run for about 5 trials, which again will just give us a little more evenly distributed points before we try and start fitting a GP. And then it will roll into our default Botorch setup, which in this case for multi-objective will be a Gaussian process and log noisy expected hypervolume improvement, where we're trying to maximize the hypervolume of the space between score and number of parameters in this case. We probably have about 2 minutes here while it churns. Any questions?
Random one, but I'm getting a bunch of minor, future warnings from Python 3.12. Is for some reason yours running a different kernel or disabled warnings? It's just a little surprising that I'm getting different.
Oh, I'm surprised too. Do you have a special collab setup? This collab should be on all defaults for us
I
at
don't
least.
think I do. I mean, I just loaded it from.
These are just future warnings, presumably from pandas.
Yeah, exactly. You know, casting behavior and replaces deprecated and will be removed in future versions, that sort of stuff, yeah.
Mia will take a look at that.
I'm just curious, you know, there might, it might be that, you know, somehow it loaded a different kernel randomly because collab runs different hardware under the hood at different times, like, I just thought I'd bring it up.
Yeah, I've seen this before. I thought that this is related to pandas like updating their replace method and they're not doing it silently. So it defaults into the way that we have it. So like internally in Axe, we are actually setting it how they want it to be. So they're not gonna like, I think they used to like have a fallback and like we don't even use the fallback currently. I looked into this because I saw it and then I didn't see it anymore, and we put out a hot fix to like make it be resolved.
It
But
could be
it's
different
really-
collab
it's really
versions
just
on
the
different
pandas,
hardware.
like-
Yeah, I wouldn't
I-
worry.
Yeah, promise.
Oh, no, I'm not.
I swear
just
we're doing it right
surprised
under
that
the
you
hood.
said
I looked into it this week.
Aaron, yeah.
Yeah, so while we're waiting, can you explain a little bit more what's happening under the hood? So do you start like one Python process per trial? And how would it be working if you would like parallelize it on a single compute instance?
If we were to, so right now we are running everything just in the one Python thread. If we were to parallelize this, what we would want to do is something like this slide here, where we're talking about the runners and metrics, and that's kind of a totally different way of interacting with Axe. In that setup, we create a class for something called a runner, which tells Axe, given this trial, how do I start a compute job somewhere else, and return metadata. And that's typically how we do things internally when we want things in a highly parallelized setting. I won't get too into it right now, but there's a lot of documentation for that on axe.dev if you're curious. Sorry?
Can you go down?
Yeah, absolutely. If anyone wants otherwise, we're really proud of the documentation that we put together in axe.dev. And there are a number of Colab notebooks that kind of walk through both what we're doing today and this closed loop experimentation setup where we're offboarding and fetching metrics from offboard machines. Carl, did you have something?
Yeah, how do you generate multiple candidates at once?
Oh, if we're still only concerned about one thread, we can just pass in max trials equals 5, 10, 15 here. When we're running everything in one thread, there's sometimes no reason not to do sequential optimization, and sequential optimization often leads to better results, in fact, because we are giving the GP more data points every time that we generate a candidate. But if for whatever reason, maybe we want to generate 5 points and then run an experiment in a chemistry lab or do something that's, off our machine, then running these in batches is really important and can be an effective way to speed wall time experimentation up. I believe we should be finished. So if anyone has any questions, feel free to raise your hand, but otherwise we should continue going on. Optimization is finished. We've run 25 trials. Once again, the number to beat is 0.78 on my machine. And what we're really looking for here, because this is a multi-objective optimization, is not a single point. We're looking for the entire Pareto frontier. So all the non-dominating points that are going to get us a score of better than 0.8 and a number of parameters less than 1,000. So we have a method here that's going to get the Pareto frontier. It outputs a dictionary, and I think people would prefer to see a data frame. So we have a little summarized method that's going to get the data frame together for us. If it will run. There we go. So it looks like we have a modest Pareto frontier where we've got about 5 trials that are giving us some strong results here. So you can see the parameterizations that led to these and the number of parameters and accuracies that we're seeing. So we're almost at 0.99, which really means that we've solved this problem for the MLP. Once again, we can pop in and compute the entire analysis. And this will pick some of the same plots and some different plots because, again, we're in the multi-objective setting. So if I scroll down here, you'll see these same arm effects, but they will be for both score and the number of parameters. You'll also see a scatter plot of how score is affected by number of parameters. So you can kind of see this Pareto front existing right along the bottom and lefternmost edge of models that we're really interested in right here being clustered. You'll see the same slices and contour plots, and we'll get cross-validation for both the score and for n parameters. N parameters, of course, just being a linear combination, the GP is getting instantly, and we see a great cross-validation on. Does anyone have any questions about this little more exotic setup of Bayesian optimization that we put together to try and reflect a more realistic set of business goals?
So for the multi-point proposal, what method are you using, and can you configure that? So if I wanted to use, my method of choice, how would I be able to do that?
I believe that the way that we do this, or I know the way that we do this by default is to just use one of the batched acquisition functions from BoTorch. So there's like Q log EI instead of log EI. And if you were to provide one of your own methods to do this that was not implemented in BoTorch, it would just sequentially continue polling the same acquisition function over and over again to get those points. So sometimes when people have that, they'll need to have a little bit of logic to make sure the same point doesn't get suggested twice. And that's something that Axe unfortunately can't handle, and you'd have to implement in your own acquisition. Is that answering the question? Cool. Sweet. We're going to do another setup here just to demonstrate some of the early stopping infrastructure. I'll blaze through the setup again here because we're just going to do the same HPO NAS. And we're going to reinitialize to get a fresh client. And we are already going to just optimize score and attach the baseline score that we've already had before. So the way that early stopping works in this ask-tell paradigm, where we're not doing a fully orchestrated run, is we still have the same outer loop. We're going to add a few more trials now that we're hopefully saving resources with early stopping. We're going to ask Axe for the next parameterization it thinks has some promise. We're going to construct the MLP and start training it. But every epoch, at the same time that we report data back, we're going to query Axe, hey, do you think you should stop this trial? By default, this is going to use a percentile early stopping strategy. That's what we use in the paper. It's very simple and heuristic based, but we find it gets great results where we just say, you have to let all of the trials run for at least about a quarter of the length. But if it is performing in the bottom half of its cohort, just kill it. It's probably not going to change rank order anytime soon. So we're going to call this method should stop trial early. And we're asking about a specific trial index here. And if it's marked, if we want to stop it early, we'll mark that we chose to do that and we'll break out of the training loop. So we're going to click run here. And this one again is going to run for a little bit. And you'll see as these logs are scrolling past that after it gets through its initialization phase, Axe will start to become confident that some arms that it's trying are just not very good and kill those to save resources so we can run more and more configurations. We find that using early stopping on top of BO for candidate generation in this joint fashion is really going to get us some sample efficiency. While this is running, do we have any? Oh, Mia, do you have something?
Yeah, I was going to point out, if you scroll up a little bit.
Yeah, of course.
We do not mark trials that have been early stopped as completed. This is like important for ensuring that the model understands like the outcome of the trial, and then it is able to use that information for future predictions.
Yes, in this whole like experiment state management and data management thing, we have a number of statuses that trials can be in that tell BoTorch or that inform Axe when it's passing data down into BoTorch, what exactly to do with that data. So early stopped trials are going to get included into the model. If we had any failures, like maybe some of these crashed MLP for whatever reason, or made our laptop we could pass those in as failures, which maybe would get ignored by the Gaussian process. So there are a handful of idiosyncrasies there that we have found to be really important in getting good experiment results in the field. Yes.
So in the case of these failures, can I checkpoint my model and then you essentially restart the process from that checkpoint or something like that?
Unfortunately, no. This is like obviously a very good idea. And we've been thinking about doing it as a team for a long time. For one reason or another, on a lot of the experiments that we run at Meta, this checkpointing has not been our first priority. So it's a very good idea, and I think it would be a good Axe feature, but it's always been next on the priority list for quite a while now.
But if we get a lot of people who want it on GitHub, then we can prioritize it.
That's right. If a lot of people are in the issues begging for a feature, then they let me work on that feature.
Yeah, sounds good. We'll do that. Actually, on that note, so I mean, there are two types of checkpointing, right? There's the checkpointing of the trials itself, but also the checkpointing of the entire optimization process.
Oh, yeah, absolutely. The checkpoint
yes.
over the entire optimization process is yeah, totally something that Axe supports. That's one of the main features that we think makes it really useful. Axe, you can either dump the entire experiment to a JSON file, which is how a lot of our open source users use it. Or if when you set up Axe, you point it to a SQL database, normally we use MySQL, it will progressively save at any kind of state update so that you can have a huge SQL database full of all your historical experiments. You can, kill an experiment when you've run out of compute resource and then resume it later when you have some more queue time, stuff like that. That's something that we think really makes a difference and helps a lot of our users. It also winds up being a good source of experiments for transfer learning if you ever need to look at your kind of history of experiments.
I have another question. If something ooms,
Mhm.
does it happen after the fact, or can you just check that before? Like having some kind of predictor that before you instantiate an object gives it a kind of feeling how much RAM it uses before it gets instantiated?
You could totally imagine doing that. Right. I mean, that's the thing about errors, though. They're always a little unpredictable. So even if you solved the problem, I'm sure there'd be another unpredictable reason that your trials could crash. But yeah, having some pre-checks to see if you want to continue running a trial, or maybe you could just run that memory estimator and then early stop the trial right away. That would be a great experiment designed for preventing any resource waste. Cool. We're going to continue on because we just hit trial 40 early stopped. And we're going to compute one of custom analyses now. So just as like a little aside here, we've been calling client.compute analyses and allowing Axe to just heuristically decide what the plots that you want are. We think we do a pretty good job guessing what plots you'd like, but if you want to produce any of them a la carte, of course, you can just pass those in. So we're going to produce this progression plot, which is this horse race plot that many people are familiar with, where you can see all of your learning curves, or in this case, score curves, and see which ones have been early stopped. So we have some early, rather poor curves from the initialization phase, which we're allowed to run through, just as the Gaussian process needed more data to learn. But towards the end, we were really shooting for the optima, and we were able to save quite a few resources by early stopping these. We're also going to summarize here while the summary is getting pulled up, just to see how many arms we early stopped, right? It's quite a few. Not having to run all of these all the way to completion is absolutely saving resources on very expensive runs.
Yeah, and what's quite nice in the progression plot, you can see as the performance starts to go down, it's like immediately early stopped, which is just really nice.
Right, and right, again, we can compute that full suite of analyses and see the same modeled in raw arm effects, the same contours and learning rate slices that we are familiar with before. Cool, I'm gonna pass it back to Mia to talk a little bit about how we can integrate Blowtorch and Axe together fluidly.
Cool, yeah, so we thought this would be particularly interesting to this community as using Axe within and taking a custom Blowtorch integration. You get all the benefits of the Axe experimentation state, the analyses, etc., and you can use your custom implementation. So what we want to hope to share with y'all here is like how to actually do that, and then to understand some of these more advanced Axe objects that might be important if you want to do so. So we're going to redo the instantiation. The reason we redo this is like to just give us a fresh start. Cool. So throughout, when Miles was talking, he explained briefly about the different strategies that were being used to generate candidates. The high level abstraction of this is a generation strategy. Conceptually, I like to think of this as like a directional DAG, where each transition criterion is an arc in that DAG. So the transition criterion defines when you should move from one node to another in a generation. The generation node are your nodes in your DAG. So we tried to keep with the DAG terminology to make it useful, but I've spent a lot of time within the generation strategy abstraction. So if I say something that doesn't make sense, let me know. And so the generation node defines what our strategy should be to generate for a specific state. So for example, you could have a transition criterion that says, oh, after we've done 5 Sobols, we now want to move into our MBM node, and then we'll start using our MBM definition for our generation moving forward. So each generation node defines a generator spec. And so it could be multiple generation specs, but that's like beyond the scope of this. And then we also have the adapter class that handles the translation between Axe and Blowtorch.
This adapter class is one of the things that I think is really special about using Axe and is what allows us to use these custom Blowtorch models very easily within Axe. So the adapter is what's going to be doing all of this data processing and all of this cleaning to get your experimental data, which is going to be messy, is going to be in kind of confusing structures, and turn that into the tensors that you want to be handling within Blowtorch. So it'll do stuff like turn your categorical parameters into one-hot encoded dimensions. It'll do stuff like turn ordered string dimensions into integers that can fit into your tensors. It'll pop stuff into the unit cube, stuff like that. And that really helps with GP performance.
Great. Yeah, so getting into the tutorial element of this, so we're going to define a custom surrogate spec here, and we're going to actually provide 2 models. One of them is going to be kind of like a bit of a weirder model that has like some SAS priors with input warping, and then we'll have just the standard vanilla GP with a matern kernel. So these are the 2 model configs, and so that'll allow us to select between them when you call into this node.
And we're using default Blowtorch models here that are developed and already exist in the library. But if you implemented your own Blowtorch model, you could just plop it in there and it would all filter through.
Yeah, you can just keep digging in the code and like getting more and more custom however you want and implementing it here. We wanted to keep it quite not as verbose for the sake of the tutorial. We'll then define a generator spec where we'll actually pass in that surrogate spec that we just defined, and we'll call this, and we'll use the Blowtorch modular generator, and then you could pass in more custom acquisition options or model gen options here. Oh, I forgot a comma. Cool, so now we're going to configure our custom generation strategy. So as we just talked about, this is how we're going to define when to use which models during the state of the experiment. So we're going to have our custom node, we're going to call it my Blowtorch node, and then it has our custom generator spec that we just defined. Notably, we don't have any transition criterion here, and if you don't have a transition criterion on a node, essentially what you're saying is that you could indefinitely generate from this node at any point in the experiment. So this is like our final node, we'll just keep being able to generate from it. We're also going to have our Sobol node, and this is saying, oh, after 5 Sobol trials, we're going to move to my Blowtorch node. And we're going to use all trials in the experiment. And then lastly, we have our center node, which again, Miles talked about. Turns out sampling at the center, really good. It's good for performance. So we'll define the generation strategy, both from center node, Sobol node to Blowtorch node. This is a really complex, abstraction. Is it making sense to folks, like the concept of this generation strategy? Cool.
In many ways, that's the beauty of Axe, right? There's in some ways it's very simple to configure, but in other ways it provides a lot of complicated hooks in order to get really custom. So the API can kind of grow in the direction that you want to grow and step back in the direction that you're not interested in.
Yeah, exactly. So now we're attaching our baseline as we have before, and then we're gonna run our experiment. That'll just provide us with the data to be able to then look at the summary and see that we're actually using the node that you have. For folks who have been asking and interested in this like custom acts with, or using acts with custom blowtorch implementations, do you feel like this is covering what you're looking for?
It's also a lot to absorb at once. We have this
Yeah.
Colab notebook on our website, and definitely reach out over the GitHub issues. This is,
Yeah.
I think, one of the most exciting parts about Axe, especially for the research community. So it'll be really great to make sure that we get our point across here. But it's also potentially a little more than is good for the last 5 minutes of
A tutorial, yeah.
at the end of a conference.
Yeah.
Yeah, but just to comment on that, so I think, yeah, definitely custom blowtorch code is definitely cool. I personally would be, okay, fix- sorry. Yeah, no, custom blowtorch code definitely makes sense for the research purpose, but I think personally, I would be also really interested in, you know, connecting it to our own libraries, whatever we're doing there, you know, which is maybe not blowtorch. Some things like SiteTune, for example, in our case, but also like, you know, people like Smack or whatever. Because they're really good in optimization methods, right? And develop new, I don't know, BO models or whatever. But, you know, having that infrastructure to run the entire loop, essentially, that's maybe not something they want to do or.
Yeah, let's actually take a minute to go to the website while this is running and pull up the EGN notebook.
Do you know where it is on you? Do you know what it is?
I do. I think so.
Sorry, I didn't mean to derail the discussion.
No. This was a perfect question because we do, right, the model selection with custom blowtorch is going to take forever to run. So this is a great time. Let me just pull this up. Where was it? Perhaps I would link this actually. We do have a abstraction though for using something that's non-blowtorch, just called the external generation node. Let's see. Any other questions while this continues to run?
Yeah, the external generation node is pretty powerful. So the generation strategy is where I personally spend like a lot of my time. I think it's like a really interesting abstraction layer. And I would be really curious as folks dive into this to like get questions on the GitHub community.
Other Docker containers is a bit more, so I can use remote client. I was asking if is there Axe Docker containers which would allow interactive with it remotely?
No, there isn't. Most of our open source users just install via pip, but I'm actually curious, what would having this Docker container enable? If this is something that a lot of people externally would find useful, that's something we should be interested in.
Yeah, just deploy it on a larger machine with GPU.
Sure.
This way you can run client on your laptop and then connect remotely to that machine.
No, that makes a lot of sense. Sure. While this is running, we can actually just go to our cheat sheet, which has already finished running.
We've got one more question.
Oh, yes, thank you.
Yeah, I've seen you using strings most of the time if you're trying to optimize or define objectives.
Mhm.
And I guess they are getting interpreted in some symbolic way. Are you planning on going for something that is more Python-esque or less stringy?
So we've gone back and forth on this as a team a number of times. Years ago, we had a way of configuring parameters and objectives that was very Pythonic. We had nested classes that each had options and config classes of config classes of config classes. And This wound up just being more difficult for us. We found it was harder to teach. Our customer teams and GitHub users were not finding it as intuitive as we'd hoped. And one of the big changes with Axe 1.0 was to introduce this string parsing for objectives and constraints. We're just using SymPy under the hood, if people are familiar with that. So thank God we're not writing our own expression parsing. But yeah, we've found that customers seem to like it. It certainly is not as Pythonic and or as type checkable as the old configs on config setup, but I think it strikes a nice balance. But no, that is a natural question.
Maybe a quick follow-up.
Sure.
Do you maybe plan on adding something like a language server that is integratable into something like VS Code or some other editor or IDE that allows for this to check this before you execute it, that you don't have a typo or something like that?
That could be interesting. We have a lot of runtime validation under the hood, so we don't try and start anything very expensive until we're sure that the user has configured things properly. But having something that can exist outside of runtime would be, even quicker time to feedback. So that is an interesting use case. Cool. Mia, do you want to head to the cheat sheet?
Yeah. At the end, yeah. Okay, yeah, so essentially the most interesting thing here, I thought that you're seeing with the summary is that we are in fact using the custom blowtorch node that you've defined. And so you can validate that that's happening. And that's kind of like the main thing. The other analyses are similar. We've already gone over those. So I think we've kind of done the meat of it all.
Yeah, I think go down to the slice plots. I do think one of the things that's very interesting in this, because right in this custom blowtorch model, what we're doing is trying to model select between this warped SAS model and the standard, single task GP. And you can see in those slices that, right, we are doing the warped SAS thing. This warped SAS model actually has been very effective for us. So I think that that's interesting to see that, right, just plugging in this different model is getting us wildly different predictions, or not wildly different, but wildly different confidence intervals here. And you can see that that structure is actually helping the optimization. Cool. That's all we have for the tutorial. If people have any questions for us, now would be a great time to talk anything from the slides from earlier in the tutorial or just Axe in general. We're happy to field everything.
If no one else is jumping in, I've got a question. You talked about how you have heuristics which decide what you want to be doing under the hood. Could you talk a bit about how that works?
Sure. So there's some ways, let me actually pull this up because I do know where that is. There are some things that the user can do to kind of influence how Axe is going to generate candidates. You can talk about like what your initialization budget is, and you can even specify things like relatively how long you're willing to spend on any given candidate generation. So right, things like single task GP are very fast. Something with model selection might be slower. These SAS models might be very slow. So there are ways that we can solicit some user input there, but then there's also just stuff about the structure of the problem, right? If we see that we're in an extremely categorical search space, we're going to use a different optimizer under the hood in blowtorch than if we were in something totally continuous. If we are doing multi-objective optimization, we obviously need to target a hypervolume improvement instead of an expected improvement. So things like that can be determined by this product of the user solicited input and the structure of the search space and optimization objective.
And then all of that is based on like our team's extensive use. Like this is what we use internally, powers thousands and thousands of experiments, and like where all of us do the research. So the foundation of that is the research.
Is empirical?
Our whole group does, yeah.
Yeah, a question on basically success of having or other algorithms like that that are a little bit different from just Bayesian optimization. Is there any current or future work in the area where Axe would be able to integrate or already does integrate with something that's doing a more different algorithm like early stopping a neural net, stuff like that?
Yeah. We have an interface that we use a little bit internally and are actually trying to improve pretty aggressively right now for early stopping. What we showed off in the tutorial was just this like really simple percentile strategy, but trying to figure out the best ways to support a platform that's expressive enough to have like really easy ASHA or really simple BOHB is something that I'm really excited about getting done and hoping to get done by the end of the year. So I think there really is something to the idea that candidate generation has been the focus for a long time in Axe, and getting a good platform for doing maybe something simpler to generate candidates and just doing early stopping at a more sophisticated level is very fruitful and going to be good for the team.
Thank you.
I'll allow myself another question then. You mentioned briefly transfer learning. Can you talk a bit about how much you support that?
Yeah. This is another feature that we have seen some success with internally and have published some papers on, and have some, if you're willing to go underneath the API, we certainly have some hooks that are able to do transfer learning. But we're still working on the exact interface we want to expose that to the user. The things that we really find interesting about transfer learning, for those of you who might not be familiar with the typical way it's done in BO, we use a multitask GP so that there's a task dimension for each of these experiments, and we try and predict how that's going to affect the target task, which is the next trial.
Can you talk a little bit about API versus?
We'll do in a moment. But yeah, so we're still trying to figure out the best way to expose that to people. We think that there's something exciting about the idea of having transfer learning very tied to the database, so that Axe can kind of naturally dig through your history of experiments and find those transferable experiments. But yeah, this is a pretty active area of research for us, and something that is really powerful in the like extremely few shot optimization things that we sometimes see at Meta, where we maybe only have 3 trials to run. What Mia was gesturing at, which I think is an important thing to note, is that with Axe 1.0, we have a very officially and cleanly carved out API now. This is something that is going to remain stable for a very long time. We have no intention of releasing Axe 2.0 anytime soon, and is the way that we recommend people interact with the library. Anything that we feel is super stable and kind of user-proof and able to fuss around with is included in this API. But anyone who's an Axe developer or a power user or really wants to do something special can obviously kind of scroll through our GitHub and find all these ways to interact with the experiment that may not be perfectly supported, but we're happy to help with if anyone runs into any trouble. Carl.
Yeah, on that topic, you can actually attach an old run to a new run, right? Or an old experiment to a related one and get transfer learning that way, right?
Yes.
Yeah, okay. So first of all, thanks for the great talk. This looks really cool. I'm just curious. So for your experimentation in Meta, can you say a little bit like how much you scale? So you said thousands of experiments. Is that essentially one optimization run scaled across thousands of trials, or what is normally how often do you? How many trials do you run in parallel on average? Something? In
that slide, we're talking about thousands of optimization runs, each of which could have, on the order of 30, 40, 50 trials. We have some settings where we're using different methods than this, mostly turbo, where we're in like the thousands of trial regime. But our real bread and butter is this 20 to 30 to 40 trial hyperparameter optimization is kind of the scale that we operate here. And at Meta, this is used by a lot of different teams, often in automated processes. And that's why this experiment number blows up so much, right? If people are retraining their classifier models on new data every day, you might as well hyperparameter tune every day as well. And that's kind of where you're seeing this number blow up.
And how much do you parallelize there? So in that regime, so how many?
In that regime, we'll do maybe 5 trials at a time, somewhere
Okay.
in there.
Okay. Do you have any idea how much X is scaling in the number of parallel trials? Or could I run thousands of trials in parallel?
I think Q log EI would break down a little bit with
Yeah.
in the thousands of trial regime. I also think there are some things in Axe in just the way that we handle data internally that if you went anything beyond 10,000 trials, some operations might just get a little slow. So I think in these like tens of thousands of trial spaces, I tend to just use an evolutionary algorithm and not worry so much about Axe. But figuring out how to scale this at a to that scale would be something that could be interesting depending on the problems that appear.
Yeah, fair. I mean, 10,000 was maybe a bit. You get the point, right?
Sure. We're very comfortable in kind of anything within 2 digits and 3 digits. Anything beyond that is maybe out of our wheelhouse, but certainly not impossible. Fantastic. Yeah. Thank you so much for all your attention and all these fantastic questions. We're really proud of what we built here with Axe and excited to get more interaction on this GitHub. So we'll be keeping an eye out for all the friendly faces and hope to talk to you soon.